Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. The ghostly messengers. Exploration of neutrinos. Deep within the atom's heart, a constant whirl unfolds. Protons and neutrons, the fundamental building blocks of matter, engage in a ceaseless dance of creation and decay. But during this energetic performance, a fleeting guest appears: the neutrino. This particle, almost weightless and lacking any electrical charge, slips through most matter unnoticed. Imagine a cosmic ninja, leaving barely a trace as it breezes by. Unlike the protons and neutrons, locked in a tight embrace within the atomic nucleus, the neutrino is a solitary entity, a lone wolf flitting through the subatomic landscape. For many years, the neutrino remained a theoretical puzzle, a missing piece in the grand puzzle of the subatomic world. In 1930, a physicist named Wolfgang Pauli first proposed its existence. He needed this invisible particle to explain a puzzling imbalance in energy during nuclear decay. However, the scientific community wasn't convinced. The idea of a particle that barely interacted with matter seemed far-fetched. It wasn't until 1956 that Clyde Cowan and Frederick Raines, in a groundbreaking experiment, finally captured the elusive particle. Their success marked a turning point in our understanding of the subatomic world. The existence of the neutrino confirmed Pauli's suspicions and opened a new chapter in our exploration of the fundamental forces that govern the universe. Our Sun, a churning nuclear furnace at the center of our solar system, constantly releases a torrent of neutrinos. Every single second, trillions of these ghostly particles bombard the Earth. They pass right through our bodies with barely a flicker of interaction. Think of it like a constant, invisible rain, one we're completely oblivious to, despite its pervasive presence. These solar neutrinos hold the key to unlocking the Sun's internal processes. By studying them, we can understand the delicate balance of nuclear fusion that fuels the Sun's existence, revealing the secrets hidden within its fiery heart. Capturing these fleeting messengers requires a special kind of vision. Since neutrinos interact with matter so rarely, traditional telescopes are useless in this pursuit. Instead, scientists have built magnificent neutrino observatories, essentially giant eyes designed to detect the faintest whispers of these ghostly particles. Imagine these observatories as colossal, shielded bunkers buried deep underground. The Earth's crust acts as a natural shield, blocking out the constant barrage of cosmic rays and other background noise that could obscure the delicate signal of a neutrino interaction. Inside these observatories lie massive detectors, some filled with thousands of tons of water or a special liquid called liquid scintillator. These detectors function like giant cameras, waiting patiently for the rare instance when a neutrino collides with an atomic nucleus within the liquid. Such a collision, though incredibly improbable, produces a faint flash of light, a brief flicker that the detectors are designed to capture. By analyzing these flashes, scientists can piece together information about the neutrino, including its direction and energy, slowly revealing the secrets these ghostly particles carry. Neutrinos aren't just celestial tourists from our local star. They stream from a variety of cosmic sources, painting the universe with an invisible ballet. Exploding stars, the violent deaths of massive suns, spew out immense quantities of neutrinos. These stellar neutrinos offer a glimpse into the final moments of a star's life, revealing the dramatic processes that occur during a supernova. Collisions between galaxies, titanic cosmic dances, also release a torrent of neutrinos. Studying these neutrinos allows us to peer into the most extreme environments in the universe, environments where gravity reigns supreme and energy reaches unimaginable levels. Furthermore, remnants of the Big Bang itself, the very echo of creation, are believed to bathe the universe in a faint background of neutrinos. By studying these cosmic neutrinos, we can potentially reach back in time to the very first moments of the universe's existence, offering a window into the birth of our cosmos. The neutrino isn't a solitary entity, but rather a family of elusive particles. There are 3 known flavors of neutrinos: electron, muon, and tau. Each flavor interacts with matter slightly differently, like siblings with varying personalities. Adding another layer of complexity, these neutrino flavors can transform into one another through a process called oscillation. Imagine a chameleon constantly shifting colors. That's the essence of neutrino oscillation. This oscillation, a mind-bending phenomenon that challenges our understanding of elementary particles, opens doors to new physics and suggests that neutrinos might have a hidden structure we've yet to fully grasp. For a long time, the neutrino was thought to be massless, a weightless whisper flitting through the universe. This assumption fit neatly into the prevailing theory of particle physics, the Standard Model. However, in 1998, a groundbreaking experiment called Super Kamiokande shattered this comfortable notion. This experiment, housed in a vast underground chamber filled with water, observed a slight anomaly in the behavior of neutrinos. By carefully analyzing the direction and energy of neutrinos streaming from the sun, scientists realized these particles possessed a tiny, but measurable, mass. This discovery was a bombshell, forcing a revision of the Standard Model and opening a new chapter in our understanding of neutrinos. A particle with such a small mass challenged existing theories and hinted at the existence of new forces and particles yet to be discovered. Neutrinos continue to pose fascinating puzzles, each discovery raising new questions. Understanding their exact mass and the intricacies of their oscillation behavior could lead to groundbreaking revelations. For instance, How does the mass of the neutrino relate to the mass of other particles? Does their oscillation hold clues to the existence of new, undiscovered forces? These are just some of the questions that drive neutrino research today. Unraveling these mysteries could reshape our understanding of the fundamental building blocks of matter and the forces that govern their interactions. Furthermore, neutrinos might shed light on the asymmetry between matter and antimatter in the universe. During the Big Bang, equal amounts of matter and antimatter should have been created. However, today, the universe is dominated by matter. Neutrinos, with their unique properties, could offer clues as to why this imbalance exists. Recent experiments have hinted at the existence of a fourth, even more elusive neutrino, the sterile neutrino. Unlike its known cousins, the sterile neutrino wouldn't interact with any of the known forces: electromagnetism, strong nuclear force, weak nuclear force. This makes it even harder to detect, a true master of disguise in the subatomic world. If confirmed, the existence of sterile neutrinos could have significant implications for our understanding of dark matter. Dark matter, an invisible substance that makes up most of the universe's mass, remains a mystery. Sterile neutrinos, with their unique properties, could potentially be a component of dark matter, offering a new avenue for exploring this enigmatic substance. While the search for the sterile neutrino continues, its existence remains hypothetical. However, the very possibility of such a particle underscores the vast amount we still have to learn about the universe and the unseen forces that shape it. Neutrino research is revolutionizing how we perceive the cosmos. These ghostly messengers, once a theoretical enigma, are now powerful tools for unlocking the universe's secrets. Studying solar neutrinos allows us to peer into the sun's heart, revealing the delicate balance that fuels its life-giving energy. Cosmic neutrinos, streaming from distant galaxies and stellar explosions, offer a glimpse into the most extreme environments, pushing our understanding of gravity and energy to their limits. Furthermore, the study of neutrino properties, particularly their mass and oscillation, could lead to groundbreaking discoveries in fundamental physics. By unraveling the mysteries of these ghostly particles, we might rewrite the Standard Model, revealing new forces and particles that govern the universe at its most basic level. The future of neutrino science brims with exciting possibilities. Next-generation neutrino observatories are on the horizon, even larger and more sophisticated than their predecessors. These colossal detectors, housed deep underground or immersed in the vastness of the ocean, will possess an unprecedented sensitivity. Imagine these observatories as giant, multi-eyed giants, capable of capturing the faintest whispers of neutrinos with unparalleled detail. With this increased sensitivity, scientists aim to precisely measure neutrino mass, further explore their oscillation behavior, and potentially detect the elusive sterile neutrino. These advancements promise to unlock a treasure trove of information, shedding light on the origin of matter, the nature of dark matter, and the fundamental forces that shape the universe. From the sun's fiery core to the farthest reaches of space, neutrinos are ubiquitous. These silent messengers, once thought to be mere footnotes in the subatomic world, have become essential tools for exploring the cosmos. By studying them, we are piecing together a more complete picture of the universe, revealing its inner workings and grand history. Our relentless exploration of these elusive particles embodies our desire to push the boundaries of knowledge, to venture into the unknown and unveil the secrets of the universe we inhabit. As we continue to unravel the mysteries of neutrinos, these ghostly messengers might just become the key to a new era of scientific discovery, forever changing our understanding of the invisible forces that shape our reality.